Hi everyone, I hope that you're well. A few of you have said that you found this question on quadratic sequences, which is a really difficult topic, quite confusing, so I'm going to go through it. Please continue to email me questions, the question numbers of any particular questions that you found difficult, so I can try and make some videos. I'll try and make a series of videos. Okay, so here are the first 5 terms of a quadratic sequence. So it's telling us even that it's a quadratic sequence. Find an expression in terms of n for the nth term rule of this quadratic sequence. Okay, so my sequence is, just write it with a bit more space. It goes 1, then 3, then 7, then 13, then 21. First thing I'll always do is look at the first difference. What's the difference between 1 and 3? Well, that's 2. The difference between 3 and 7 is 4. 6 and 8. Hopefully we can see a pattern there. It's going up in 2 each time, and therefore that is what my second difference is. My second difference is 2. If it didn't tell us it was a quadratic sequence, that would be the thing that told us that it was. If the second difference was the same, i.e. this level was the same, then it's a quadratic sequence, whatever this number is. Yeah. Unfortunately, this is no mark so far, but the next step is our first mark. Whatever the second difference is, we divide that by 2, and that is our coefficient of n squared. So 2 is our second difference. If I divide that by 2, it obviously gives me 1. So that's my coefficient of n squared. Will be 1n squared. That's how my nth term rule is going to start. So if, just to be clear, my second difference was, say, 6. Say this was 6, 6, 6. Not a good number, guys, but 6, 6, 6. And then if I divided that by 2, then that would give me my coefficient, which would be 3 of n squared. Or say this second difference was 8. Divide that by 2, it would be 8n squared. The second difference divided by 2 is my coefficient of n squared. This is my first mark. Now, this is where it gets a bit more confusing. So just to be clear, instead of writing 1n squared, we don't normally write coefficients where they're 1. It's just assume that it's 1 there. Okay, so this is where I encourage you to draw a table. Okay. Now I know the beginning of my term is going to be n squared. The beginning of my nth term rule, apologies, yeah? And if we remember, for my first term, I know n is equal to 1, just like in any sequence. For my second term, n is equal to 2, n is equal to 3, 4, 5. Yeah. Okay, so if n is equal to 1 for my first term, that tells me the position in my sequence, remember. So I'm going to do 1, and it's because it's n squared, so 1 squared, which is 1. For n equals 2, so n equals 2, so 2 squared is going to give me 4. N equals 3 for my third term, 3 squared is 9. Here it would be 16 and 25. Now, I'm going to put in my term. My term is just the thing, the sequence, basically, yeah? So these are my terms, 1, 3, 7, 13, 21, etc. So 1, 3, 7, 13, 21. Then I'm going to look at the difference between n squared and my term. Well, 1 take away 1 gives me 0. 4 take away 1 gives me 3. 9 take away 7. Sorry, how do I get from here to here? I take away 1. That's a better way of saying it. Sorry if that confused you. How do I get from here to here? I take away 2. How do I get from here to here? I take away 3. And how do I get from here to here? I take away 4. Yeah, so minus 3 and minus 4. Then what we're going to find, typically, sometimes this will just be constant, in which case then whatever the same number is, I'll just add on to my n squared. But in this case, it's forming another type of sequence. It's forming an arithmetic sequence. So what's happening in this sequence? Well, I take away 1, take away 1, take away 1. This is an arithmetic sequence because it's going up or down in the same thing. So if it's going down in 1 each time, I know it's going to be minus 1n. And then I think, what would my term before that be? So if I'm taking away 1 this way, I'm going to add 1 this way. So this is my nth term rule for this sequence. Then all I do is I take the first thing and I just plonk this bit on the end. Yeah, so I'm going to have n squared minus 1n, add 1. But as we just discussed, good mathematicians are not going to put the 1. Worthwhile practicing, guys. It's easy enough if you just Google nth term of quadratic sequences, or just put quadratic sequences and it'll probably come up with some nice questions. In the event that you would like more questions, please contact me. Thank you. Bye.